Let's welcome our first group. Julia and Whitney should be the other one.
Okay, so my component was over instruction memory, and Julia, by the way. I feel like whenever I started doing this, I didn't really know a whole bunch about instruction memory, and I think I'm just as confused as I was when I started.
Excellent.
Okay, so I feel like where she started, what is instruction memory? Definition I found, it is a state element that provides read access to the instructions of a program, and given an address that input supplies the corresponding instructions to that address. It only stores the instructions in here, and that's where it kind of doesn't write or anything like that, just reads in the instructions, and then it'll output into wherever it needs to go. So it sees what the counter thing is looking at, and then it'll take whatever that is looking at, and then it'll give it to wherever it needs to go, because depending on what you're trying to do, depends on what data path it's going to follow. I mean, it's always going to go to the control realm where the decoder and stuff is, but whatever's being read, it might need to go to sign extension, it might need to go to the MUX or to the register, just depending on where the data path is, depends on where it's going to be sending what was read in. So my overview of implementation, I did a lot of research on trying to figure out about implementing it. Wasn't very successful, but from what I gathered, so first thing you need to do, obviously, is create your module and everything like that, which includes the input memory clock, input instruction address, and the reset and the output instruction. The input signal and output, input signal address and the output signal instruction, there's only 32 bits. They can't be 64 bits because it only brings in 32 bits at a time. That's from what I gathered. Might be wrong.
That is correct.
So you need to create a memory array, so there's a placeholder available where you can store in the instructions, and there needs to also be, there's like, I think, 2 always instructions, which does the reset and the clock, and does the loop to determine what needs to happen whenever a reset is equal to 1, or the reset is equal to 0, or the clock is equal to 1, and the clock is equal to 0. Issues implementing, I guess my issues mostly were trying to figure out the loops and what needs to be done and how they need to be organized correctly. Because honestly, going from structural to behavioral is a little different and kind of a little confusing, so I didn't really know how to go about doing the behavioral style. And those are kind of where I had some issues trying to figure out how to do that. And then, also remembering to put that finish so that loop, so that it knows when to stop. So behavioral style is the style that was used for my instruction memory. From what I researched, I feel like behavioral style is used mostly for instruction memory because it there's more control over like what you need to do, because in structural there's not as much control. I mean, it does have to do certain things before it do another one, but in behavioral you need to these are like directions and instructions, and they need to do something specific in order for it to work out. So that's why I think behavioral style was the reason that I had to use behavioral style for the instruction memory, was because it has more control over what is happening. I think, I'm not quite sure, but that's from what I got in my research.
Fair.
And that concludes my presentation. Thank you.
The red pill. No, the red pill. What do you think of the red pill?
The red pill.
Ah.
Oh no, it's too late.
Oh.
We're watching the red pill.
Yeah, why is the whole movie?
Oh, that's
That's a whole.
Oh, I love it how they ask, you know, it's all like, do you take the red pill or the blue pill? The first thing that goes in my mind was, well, what happens if you take both?
Well, they're both programs. They're basically, so what would happen if you tried to run both the programs?
Right. I mean,
That's what he explains to it, is that he's like,
What's that?
Is your body multitasking?
yeah. Do I get true duality here? All right, so hold on real quick. Oh yeah, any questions for Julia? Since I guess she'll answer them through me.
I like her honesty.
I like her
I
honesty.
do, yes.
It's like, it may be this. I'm not quite sure.
Let's see. So what is instruction memory? Oh yeah, by the way, Julia, good job. Before I forget, good job. Yeah, everyone.
Yay. Thumbs up.
I like how you say it out to the air. Good job.
Good job, good job, good job. Julia out in the air. So I just love how we have.
Well, if you're recording this thing.
Yeah, I'm recording this with my whole thing on the side. Anyways, good thing to do when you're talking about something is more high level. You did mention what the purpose of the instruction memory was, but especially here, it's best to remind your audience that you're talking about fetching instructions so that the rest of the data path can execute whatever needs to happen. So instruction memory is fetching, hey, okay, what are we doing in this instruction? Answering that question. It's just a better way to put what you said, Julia. I mean, you said it in other words, but just make sure it's high level, and you want to go high level first and then go into the details of like it goes to the MUX, goes to the register file, et cetera, et cetera. And I think that was the big thing. Behavioral, why does it have to be behavioral? You did mention, you mentioned a lot of good points. One thing I want to clarify is you said that it was more control. It's not so much that it's more control, is that the behavioral acts more of what's the behavior, aka what's the response to certain inputs, as opposed to structural where you're laying down the gates on a circuit. Behavioral is like you have this input, these are going to be the outputs. You're defining the behavior. And the reason why we do that in instruction memory is because memories are usually very unique in their structure. So for example, instruction memory can be SRAM, which is done with a certain type of gates, or it can be DRAM, which is done with capacitors, or it could be flash, it could be a straight up ROM. There's different ways to do it, and unfortunately those are not easily specified in Verilog, which is why you just do it behaviorally in order to simulate it. Okay, but besides that, good job. Any other questions about the instruction memory? Since remember, this is to help all of y'all. If not, let me turn off that buzz, because it is pretty bad. All right. Okay.